Hi folks, today we're going to talk about sound. We're going to start with this. As you look at this, you realize you're looking at waves. You're looking at wave after wave after wave coming in to shore. All right, this was taken in Hawaii this past summer. Right, sound travels like a wave. They come one after another after another. So when we look at waves, there are a couple things we can tell about them. We can tell something about amplitude. How big is the wave? How tall is the wave? Well, that applies to a wave. When we think about sound, it also applies to sound. We have certain wavelengths. How close are these two waves? What is the length? What is the distance between two waves? All right, that's wavelength. Frequency. If I think about waves hitting shore over and over and over again, right, these waves, which have already hit shore, this is sand, but bottom line is these are very close together. These waves are very far apart. So these waves are frequent, and these waves are not frequent. So when I look at these waves, their wavelength is very short. This wavelength is very long. So the more frequent something is, the shorter the wavelength. The longer the wavelength, the less frequent something is. All right. So if I have something like this red line over here, this red line, this one over here, right, has a very long wavelength, and hence it has a low frequency. Whereas this wave has a very short wavelength, and hence will hit you very, very often and has a high frequency. If I look at how high the waves are, this wave is that high. It's the distance from the origin, or the middle, to the top, or the middle to the bottom, it doesn't matter. And if I look at the big wave, it goes all the way up to here, so it has a very high amplitude. It is very big. Okay. So as we think about sound, right, the bigger the wave, the louder it is. The shorter the wave, the less amplitude, the quieter it is. The shorter the distance between these two, the shorter the wavelength, the higher the frequency. In other words, the pitch goes up, the note, if you will. If you think of it like a piano, you're playing the right-hand side, you're playing the high notes. Whereas over here, with something that has a very long wavelength or a low frequency, you're playing one of the low notes. All right, that's it for sound. Sound has amplitude, how loud it is. It has wavelength, what pitch it is. And the sound has frequency. And frequency is inversely proportional to wavelength. Really? Let's look at that, right? As the wavelength gets shorter, the frequency gets higher, gets more. As the wavelength gets longer, the frequency is smaller. It hits you less often. All right? That's it. You have a short worksheet to do. When you're done with that, if you have any questions, please see me. Otherwise, you're ready to take your test. Have a great day. See you soon.